There we go. All right, hello everyone. In this video, we're going to cover page 7 and 8 in your Unit 1 packet. I should say this is for honors chemistry. And we call this our observing lab. We also call it our XYZ lab. And really kind of the whole purpose of this lab is for us to practice our observation skills. And before we get into the lab, the first thing that you're going to want to do is go ahead and make a data table or a T-chart on page 8. And you might want to pause the video here. There's kind of 4 things that we're going to take a look at where we're going to need to make some observations. And so on the, it's going to be flipped, but again, on the left side, on your left side, I kind of have the procedure part that we're going to look at. And then on the right side, I have space to make some observations. Where again, an observation is using our senses to gather information, to describe what's happening. So again, you can always go back to that. You can pause the screen here and copy this down on page 8 because you're going to have to take a picture of that and turn it in. And let's kind of get going here. And I just realized I need to get some foil, so I'll be right back. And magic, I got my foil. So, all right. So let's kind of break this apart. So I'm going to start with my procedure. And first thing that I need to do is measure about 25. Notice it just says approximately or about 25 milliliters of Z into a beaker. It doesn't specify an exact volume, so I'm just going to pour this in, put it in Z, in about 25 milliliters. It's good enough. Again, doesn't need to be exact, it just says about. And then it tells me that I need to get some middle foil about 2 by 2, a squarish. Again, I'm just going to ballpark it. I'm not going to be exact. A bit more rectangular here than the other thing. And it is going to go into liquid Z. And it tells me that the reaction might start slowly, so I'm just going to kind of leave that. So I can just kind of say initially here, as I look at that observation, if I was to write some things down on my paper, liquid Z is a clear, colorless solution. I'm wafting. Doesn't really have a smell. Foil, shiny, silver. Again, nothing really happening yet. So I'm going to leave that there, and I'm going to move on to the next step, number 3, because again, this might take a while. Now I need to do the same thing with liquid Y. So again, I'm going to grab a beaker. It says about 25, so I'm just going to kind of estimate it. And I want to get another piece of foil. Again, I'm just going to ballpark this. And again, same thing. It tells me to put my foil crumpled loosely into liquid Y. So there it goes. And again, if I was to make my initial observations, liquid Y is that clear, colorless solution. Our foil is shiny, silver colored. Again, if I wanted to just take a little waft, not really getting any smell there. So again, we have 2 colorless, clear liquids. We have foil in each, and we're just going to kind of let those sit. Again, the reaction, if something happens, it might take 8 to 10 minutes. So I'm actually going to kind of put these off to the side. And again, I should have been a little bit clear on this. Hopefully you've kind of made some of those initial observations now on page 8 for Z and foil and Y and foil, just describing your initial observations. Clear, colorless liquids for each of them. The foil is shiny and metallic. And initially there's no change. There's nothing going on in either beaker. All right, so again, I'm going to put these off to the side and let them sit there for a while. And then I'm going to move on to my next step. So next, it says I need to get some crystal X. So this is kind of that third part on our little data table. And again, I would probably write down some of those initial observations. Crystal X, it's not showing up too well on camera. It's actually green in real person, in real life. And it asks me to use my spatula. Boom, spatula. And just a small amount This is what I'm going to use, that small amount right there. And again, it's a green solid, small crystals or small flakes of it are in there. And that is X, so that might be my initial observation under the X and Y part of my data table. And now I need to measure exactly 21.2 milliliters. So I want a graduated cylinder. And we're going to talk more about measuring really soon, about how we actually read measuring devices. So I'm not going to worry too much about practicing on this. We're explaining how to get it right. That's like 21. I do have a pipette. There we go, Butterfingers today. To get a small amount there. Boom, boom, boom. Okay. And again, Y we already know is a clear, colorless liquid. And then what it says is to add liquid Y to beaker X. And don't stir, and we want to observe. So I'm going to add liquid Y. And if we kind of make those initial observations, again, kind of hard to see on camera, slowly spreading out like a green color. Again, it's going to look more blue on camera, but in person it's a green. Looks like those crystals might be dissolving. And what I'm going to do, just to kind of save you all some time on the video, is I'm going to pause the video and come back in a couple minutes. All right, and we're back. So now it says to stir the crystals until they dissolve. And as I stir it, they are dissolving. So that is another observation you can make. And now your eyes do not deceive you. Our crystals X have dissolved, and our solution is blue. Again, it's a very lovely blue color. So in the third part, X and Y, you could say once the crystals have dissolved, the solution turned blue. Still clear. Again, notice that there's nothing really hanging in it. It's not cloudy. It's still a clear solution. And now the last thing that I want to do in step 9 is to add another piece of foil. I'm going to add a piece of foil. Boom. I'm going to add 2 here. And press it down with a stirring rod, glass stirring rod. Just going to press it down, making sure this reaction happens. So again, this would be that last row on our little T-chart of observations. Oh, and awesome. We're already starting to see a reaction here. So let me kind of hold this up and a little bit closer to the camera. So we have a kind of a reddish brown solid forming. It almost, oh, we got some bubbles on the foil. Again, probably hard to pick up on the camera, even though it's supposed to be HD. But we do have some bubbles forming on the bottom of the foil, and we have some reddish brown chunks forming. Might be able to see that a little bit better there. There, look, we got some reddish brown chunks forming. So that's kind of really cool. So some observations for that last row. Once we add the foil, we get bubbles forming on the bottom of the foil, and we get a reddish brown solid being formed. Now, I'd be hesitant to say rust. We don't know what that reddish brown solid is. So we don't want to make an inference. We don't want to try to explain. We just want to describe what we're seeing, and that we have that reddish brown solid forming. And again, it kind of looks like the foil is breaking apart a little bit. We got some bubbles on there, but those are all good observations for that last row. I'm still waiting for part A, that first part, to happen. The reaction's happening a little bit, but what I want to go ahead and do is show you guys what this last part looks like overnight. So this is what happens when you leave it overnight. You'll notice we have the reddish brown solid at the bottom, and what's happened to our liquid? Look, the liquid turned clear. So given enough time, our liquid will turn clear. So that's kind of cool. And we'll just kind of leave those there. And now I think I can show you guys part 1, YN foil. No change, no observations, no changes occurred. But with our foil in liquid Z, so again, this is liquid Z we're looking at. Again, kind of hard to tell. We got some bubbles forming. There you go. You can kind of see it there. We have bubbles forming. There's a kind of a gas coming out the top. Again, it might be hard to see, but we have a reaction that's starting to occur. Bubbles tells us a gas is forming, which is one of our signs of a chemical reaction. And it's starting to pick up steam here, so I just kind of might let this keep going to get real vigorous and show you what that looks like. And again, I did this yesterday, so I want to show you what it looks like if it's allowed to sit overnight. So notice sitting overnight, our foil is completely disintegrated, is completely broken apart by liquid Z. So again, some more observations you can make. Oh, there we go. Now the reaction's really taken off. Look at that bubbling. Might be able to see, yep, I think you can see the gas being produced. Don't want to inhale this gas. It's kind of why I'm keeping away from my nose. It's actually hydrogen gas, which is flammable. If anyone is a fan of history, the Hindenburg, one of our early blimps, was filled with hydrogen gas. One of the reasons why it exploded was because it was filled with hydrogen gas, and safety protocols, the safety procedures weren't perfect there. But again, turning dark gray, really bubbling, really fizzing. We have a really strong reaction occurring with our foil and Z. So finish making your observations and then follow the directions to complete the assignment and submit those.